Hey everyone, we are continuing to learn how to do integrals of more complicated functions. And so I'm given this function right here. And remember, one of the things I look for u is that it is of a higher power, or that the derivative of whatever my u is somewhere else here. I don't really see that, but I still see that x plus 2 is inside the square root. So I'm going to still let u be x plus 2. Now I'm going to take the derivative, and then I make my substitution. I get x and then the square root of u and then du. Right, now something went wrong. I still have an x here. I don't want that. So I need to somehow substitute this x out. Now I do know a relationship between x and u. I have it right here. So what I can do is take this and say x is u minus 2. So I can continue my substitution. And now I do not have any x's in my equation. Right, so I substituted x for u minus 2. I got that from my original u equation. Right, u to the 1/2 is the same thing as u to square root of u, and then du. Alright, now if I want to evaluate this integral, it's probably easier if I distribute this first. So I have u to the 3/2 minus 2u to the 1/2 du. Take the integral, so I have 2/5 u to the 5/2 minus 2 times, this will be to the 3/2, so 2/3 u to the 3/2. Now plus c because this is an indefinite integral. And so I'll just do a little bit of simplification. Right, and I'm done. Alright, so the only thing that was different was I had to substitute an extra x out, but that's fine. Alright, so same deal here. Now I'm going to let u equal x plus 1. Now I'm just going to rearrange this a little bit. So I have x plus 1 to the negative 1/3 power. I have x, and then I have dx. So these are all the things that I need to get rid of. So I'm going to let u equal x plus 1 because it's inside the function. It's complicated. Something's happening to it. Now du is going to be dx, so that takes care of this business. So this is equivalent to u. This is equivalent to du. I still need to get rid of that x. So I know that x is equivalent to u minus 1. They're the same thing. So that means this x right here is u minus 1. Now I can substitute every part out. I have u to the negative 1/3, u minus 1, du. Okay, now same thing. It's probably easier if I distribute this. So I have the integral of u to the 2/3 minus u to the negative 1/3, all with respect to u. And so I take the derivative. I'll get 3/5 u to the 5/3 minus 3/2 u to the 2/3 plus c. Alright, one more example here. This time a definite integral, so I gotta change my bounds as well. Alright, so I'm gonna let u equal 2x minus 1. I know I'm gonna have to substitute this x out, so I'm gonna go ahead and solve. I get x is u plus 1 over 2. Okay, now du is going to be 2 dx, which means that dx is equivalent to 1/2 du. Okay, and then I know I'm going to have to change my bounds, so I'm going to go ahead and take care of that now. So when x is 1 and x is 5, u is going to be 1, and then u is going to be 9. Alright, so I'm just going to rewrite this a little bit just to make everything really clear. So I have 2x minus 1 to the negative 1/2 power. I have an x, and then I have a dx. So these are all the things I need to substitute out. Okay, I just moved this to the numerator. Now I'm letting 2x minus 1 be u. Right, that's what I said. X is the same thing as u plus 1 over 2. Okay, that's what I found out from my original u equation. Dx is the same thing as 1/2 du. Right, so these are all the things that I'm substituting out. Now I'm also changing my bounds. So instead of 1 to 5, it's 1 to 9. Okay, I have u to the negative 1/2 power. I have a u plus 1 over 2. And then I also have a 1/2 du. Right, so these are, I just substituted, but I think, I wrote it out right here. So these are all the things that I substituted. Nothing really changed that much. Okay, now I'm going to take this 1/2 out. Then I have 1/2 here as well, and I'm also going to take that out of my equation. So 1/2 times 1/2 is 1/4. So I have u to the negative 1/2 times u plus 1 du. So I took this 1/2 and this 1/2, took them out. Now I'm going to distribute this. So I have u to the 1/2 plus u to the negative 1/2 du. Okay, now I'm going to take the integral. So I'm going to have 2/3 u to the 3/2 plus 2u to the 1/2 from 1 to 9. And so I'm just going to plug in 9, plug in 1, see what happens. So I have 1/4. If I plug in 9, I'm going to get 18. And if I plug in 9 here, I'm going to get 6. If I plug in 1, sorry, it's going to be a minus. So if I plug in 1, I'm going to have 2/3. If I plug in 1, I'm going to have a 2 there. Right? And you do the math, you get 16/3. All right, let's move on to the back. Now let's just talk about symmetry real quick. So if I have an even function like, I don't know, parabola. Okay, if I want to take the integral from negative a to a, so like this area right here, yeah, I can see that because I have even symmetry, meaning I reflect it across the y-axis, these areas are equivalent, they're the same. So that means that I could instead just look at half of this and multiply it by 2. So my integral from 0 to a times 2 would be the equivalent of this whole thing. Okay. Now if I have odd symmetry, so an easy example is just linear, and I go from negative a to a, so I'm looking at these areas here. Remember, if you're under the x-axis, you're going to be negative. So this is negative, this is positive. They look the same. So these will cancel out, right? So they're going to cancel, and so my overall area is just going to be 0. All right, now let's use these facts to answer some questions. So first, they tell me my function's even, and they tell me that the integral from 0 to 5 is 3. That's all the information I have. So that means that from negative 5 to positive 5, that's going to be the same thing as 2 times the integral from 0 to 3. Sorry, from 0 to 5. So that's just going to be 6. Okay, the integral from negative 5 to 0 is going to be the exact same as the integral from 0 to 5. So that's also going to be 3. Now the integral from negative 5 to 5, but times 4, so we already found what that is at 6, so it's just going to be 24. All right, now the integral from negative 5 to 5, this time my function being odd, well, these are going to cancel out, so it's going to be 0. All right, and the reason why they cancel is because the integral from negative 5 to 0 is going to be of opposite sign, so it's going to be negative 3. And so negative 3 plus 3 is 0. That's why I got a 0 here. Right, and then 4 times 0 is 0. All right, that's it. See you later.